Welcome to the Z-Hut. Today we're going to take a look at controlling a pan and tilt platform with a joystick. Now these platforms are very inexpensive. They're just a few dollars on eBay and Amazon. They're a little bit more. And you can get them either with or without the servos. I got mine separate, the servos separate. I would recommend getting this item with the servos because I had to modify one of the arms to make it fit in the bottom here. It didn't come with the one that was actually designed for this, but it does still work, just slight modification needed. Alright, so I got a joystick here. I'm going to demonstrate it working real quick, and we'll take a look at the setup, and then we'll take a look at the simple sketch we're using to control this. Nope. Got wrapped around the wire there. When you do finally set this up where you're going to be using it, I would recommend, securing the wires so that they don't interfere. But for this demonstration, I think we'll be good. As you can see, the pan, tilt, everything is controlled by the joystick here. Now, we just simply have two servos, and I've got that on the X is on pin 3 and the Y is on digital pin 5. Now if you go and you set this up and say you push to move it to the right, or you go to move it to the left and instead it moves up or down, simple solution, just switch the two leads. That's all you got to do. Now depending on the orientation of how you have your joystick, in the programming, say if you push to move it down and it goes up instead, it's backwards, that's taken care of in the programming. It's actually real simple. And the same thing if you push it to go like left and instead it would go to the right. In the programming we take care of that. The way I've set it up in the orientation of the joystick, I didn't have to do any modifications, but when we get to the sketch, I'll show you it's super simple. So besides the pan and tilt platform, we just have a analog joystick here, and you have a ground pin, a 5-volt pin, and then you have the X and the Y axis, and then there's also a push button, but we're not using that in this demonstration. Now I have the X and the Y axis connected to analog pin A1 and A2. Now also, when I was saying before, if you went to move it side to side and it was going up and down instead, you could also switch these two wires as well. Whichever is the most convenient for you to switch. It just means you got your X and Y mixed up, and just switch either of them will solve the problem. All right. Other than that, we've got power running from the Arduino. You've got your middle, which is the positive. On these micro servos, the orange is your digital pin, the pin that goes to the Arduino digital pin, and the brown is ground. That's all there is to set it up. And I just got mine with some two-faced tape here on this little piece of plastic, because otherwise it liked to tip over when I was using it. All right. With that, let's get over to the sketch, because that's pretty much what controls the whole thing. And also remember, you could do a wireless version of this. You just need two Arduinos, and you'd need two Bluetooth modules. You'd need a slave and a master, so an HC05 and HC06 would work perfect for that. And just have one Arduino board with the joystick, and then have the other Arduino board with the pan and tilt, and then you could be wireless control this. That'll be a different video. I'm also going to be doing a video on how to use your smartphone to control this, and that should be the next video uploaded after this one. So, all right, with that, let's get over to the computer and take a look at the sketch. I'll catch you there in just a second. All right, I've got the Arduino IDE opened up here. Now, for a copy of the sketch, if you want to try this out yourself and don't want to just type the whole thing in, look in the description below, and you'll find a link to this project's website, and I will have this on there, and you can just copy it off there and then paste it into your Arduino IDE. There will also be links on there too for that pan and tilt platform, the micro servos, joysticks, anything associated with this video. You can find links to get the parts if you don't already have them. All right, now for the sketch, let's just get right into it here. So first we're including our servo.h library. You should have that in the Arduino IDE. That should be built in, so unless you accidentally deleted it, you should not have to download it. Then I am setting up the names for two servos. I'm just calling it Servo X and Servo Y. And we need two integers, and these integers we're going to be storing the values we're getting from the joysticks. Actually just joystick, and I just named that val X and val Y for the X and the Y. In the void setup, we're just attaching our two servos, and I'm putting the X on digital pin 3 and the Y on digital pin 5. Then in the void loop, and wow, this is complicated, isn't it? What we're doing first is we're just doing an analog read. So we're setting the integer val X, that's our x-axis, to equal analog read A1. So we're reading the x-axis of the joystick. Now that value we're getting is going to be between 0 and 1023, but for the servo we need to write to it, we need a value of 0 to 180. So what we're doing is we're taking the val X and we're mapping it. And this is where it comes in, I was talking about before. If you go, your x-axis is going backwards, so when you push down it would go up, or if you went up it went down. What you do right here is to fix that, you change this 0 to the 180 and then change this 180 to 0. Now if it's happening on the y-axis, it's going left instead of right, or it's going right instead of left, just switch the 0 here to 180 and the 180 switch that to a 0. Just reverse these two numbers. That's the easiest way to do it. I would leave this alone here. Just things to get a little confusing. I always like to change the last two in the mapping, just so it's a personal preference. So I remember when I'm going through if I'm modifying or updating a sketch. All right, I hope that makes sense to you. So we're moving on. Now that we have that value mapped, we're just writing to the servo. So we're doing servo X, and we're writing val X. That's our value from the joystick that's now been converted to a value of 0 to 180. And then we're just giving it a delay of 15. That's milliseconds. Just a real quick delay to keep things flowing smoothly. Give the servo a chance to move before it's getting another reading. And you could actually bump this up. Now that I think about it, maybe more of like a 25 to a 50, but the 15 does seem to work. Just play with it. If you're getting glitches, and I did, if I was really moving it around quick, I did once or twice get a glitch, and what it does is it just shuts down for a moment. This is what's going on here. Just increase that delay, and I should, matter of fact, I'm going to change that right now before I put the sketch on the website. I'm going to change it up to 25, and that should keep things moving smoothly. But if you do get a glitch, it's glitching out, just increase that number some more. All right, after that delay, what we're doing is we're just doing the same thing that we did for the X, but we're doing it for the Y-axis, the left and right. Oh, excuse me there. I thought I was going to sneeze. Allergies are bugging me a little today. But like I was saying, it's just the same thing as we did up here in the x-axis, the up and down. Now we're doing it for the y-axis, the left and right. And that's all there is to this sketch. So, well, I'm going to go ahead and wrap this video up. There ain't really anything else to go over. Remember, I am going to be uploading some more videos playing with this. We're going to control it with a smartphone. That should be the next. And then after that, I do believe I will be wiring up with two Arduino boards and the Bluetooth, make our own little remote control for this. And so don't forget to subscribe. please give the video a like if you found the information useful, and well, remember to share. Your friends might like this too. So, all right. With that, thanks for joining us here today. Hope you have a great day. And remember, always wear your tinfoil hat when you're building and programming your Arduino. We don't want the government or the aliens to know what we're up to.